Hello students, in this video I am going to discuss about some numerical problems of electricity for class 10. Before starting the sums, let me discuss the basic relations that are required to do the numericals. Here first formula is I equal to Q by T, where I is the current, Q is the charge and T is the time. Second formula is V is the potential, so potential is work done by charge. Third one is R equal to rho L by A, R is the resistance, rho is the resistivity or specific resistance, L is the length of the conductor and A is the area of cross section. Fourth one, which you got from Ohm's law, V equals to IR, where V is the potential difference, I is the current and R is the resistance. Fifth one is work done, W equals to Q into V, where Q is the charge and V is the potential difference, equals to IVT equals to I square RT equal to V square T by R. For power, which is P equals to product of potential difference and current V into I, which is equals to I square R, which is again equals to V square by R. Seventh one is resistances in series. When resistances are in series, then equivalent resistance is sum of all the resistances, that is R1 plus R2 plus R3. In case of parallel resistances, suppose overall resistance is Rp, then 1 by Rp will be 1 by R1 plus 1 by R2 plus 1 by R3. And the last formula that is required is electrical energy equals to power into time. With this knowledge, now we can start the sums of electricity. From practice problem 1, question number 1 is, what is the electric potential at a point in an electric field when 24 joule of work is done in moving a charge of 84 coulomb from infinity? In question number 1, it is given charge Q is 84 coulomb, work done is 24 joule, and we have to find the potential. We know the relation that V equals to W by Q. So V equal to W is 24 and Q is 84. If I cancel by 4, 4 6 ja 24 and 4 21 ja 84. Again cancel by 3, 3 2 ja 6, 3 7 ja 21. So we got 2 by 7. Now if 2 is divided by 7, 2, if it is divided by 7, 7 0 ja 0, 2.0, 7 2 ja 14, here it will be 60, 7 8 ja 56, so 40, 5 7 ja 35. So just keep 3 places after decimal. So 2 by 7 will be 0.285 volt. Therefore, required potential is 0.285 volt. In practice problem 2, question number 1 is, work of 25 joule and 30 joule is done when 5 coulomb of charge is moved from infinity to a point A and then to a point B respectively. Calculate the potential difference between the points A and B. Now for point A, work done is 25 joule and charge is 5 coulomb. So here potential we know it is W by Q. So we have to write W1 by Q, that is 25 by 5, which will give 5 volt. Again potential at point B, it will be W2 by Q. W2 is 30 joule and Q is 5, so it will be 6 volt. Therefore potential difference between points A and B, it will be 6 volt minus 5 volt, or we can write V2 minus V1, which will be 6 minus 5, that will be 1 volt. Therefore 1 volt is the required answer. In page number 125, in practice problem 1, first question is, a wire of resistance 4.5 ohm and length 150 centimeter has an area of cross section of 0.04 centimeter square. Calculate the specific resistance of the wire in SI units. Here resistance is 4.5 ohm, length of the conductor is 150 centimeter, area of cross section is 0.04 centimeter square, and we have to find the specific resistance. Now we know R equals to rho L by A. So rho will be RA divided by L, RA divided by L. Now resistance here it is 4.5 ohm, area of cross section is 0.04, divided by length is 150 centimeter. These two are in centimeter, this is in ohm. This can be written as 45 by 10 into 4 by 100 into 1 by 150. Now 150 and 45 can be cancelled by 15. 15 10 ja, 15 3 ja. So it will be 3 4 ja 12 divided by 1 2 3 4. 1 2 3 4. This is ohm centimeter. Now since in the question it is given that it should be in SI unit, so it should be converted to meter. So it will be 12 divided by 1 2 3 4 into 100, then it will be ohm meter, because 100 centimeter equals to 1 meter. Now in the next step it will be 1 2 3 4 5 6, so it will be 0.123456 ohm meter, which is the required answer. In practice problem 2, question number 1, resistance of a conductor of length 75 centimeter is 3.25 ohm. Calculate the length of a similar conductor whose resistance is 16.25 ohm. Here R1 is 3.25 centimeter, L1 is 75 centimeter. In case of second wire, R2 is 16.25 ohm and L2 we have to calculate. We know resistance is directly proportional to the length of the conductor. We can write resistance proportional to length. So we can write R1 by R2 will be equals to L1 by L2. So L2 will be R2 by R1 into L1. Now R2 we know it is 16.25, R1 is 3.25 into L1 is 75 centimeter. If I remove the decimal, it will be 16.25 by 325 into 75 centimeters. Now 1625 can be divided by 325, which will give 5. So 5 into 75, it will give 375 centimeters. Page number 127, practice problem 4. Question number 1 is 4 resistors of resistances 1 ohm, 2 ohm, 3 ohm and 4 ohm are connected in series. Calculate the resistance of the circuit. Here resistance 1 is 1 ohm, second one is 2 ohm, third one is 3 ohm and fourth one is 4 ohm. And here it is given that resistors are connected in series, and since they are connected in series, so total resistance Rs will be R1 plus R2 plus R3 plus R4. Now R1 is given 1, R2 is 2, R3 is 3 and R4 is 4. If I add this, then I am going to get 10 ohm. So 10 ohm is the overall resistances in series. In practice problem 5, question is 3 resistors of 24 ohm, 12 ohm, 8 ohm are connected in parallel. Calculate the total resistance of the circuit. Now here R1 is 24 ohm, R2 is 12 ohm, R3 8 ohm, and here it is given that resistors are connected in parallel. Since they are connected in parallel, so overall resistance, suppose it is Rp, will be equals to 1 by R1 plus 1 by R2 plus 1 by R3. So it will be 1 by 24 plus 1 by 12 plus 1 by 8. Now if you take the LCM, LCM will be 24. LCM of 8, 12 and 24 is 24. 24 divided by 24 is 1. So it will be 1 plus 24 divided by 12 is 2. So it will be 2. 24 divided by 8 is 3. So it will be 3. So 3, 4, 5, 6. 6 by 24. 6 1 ja 6. 6 4 ja 24. Therefore, Rp equals to 4 ohm, which is the equivalent resistance. In practice problem 6, question number 1, what resistance should be added to two resistors of 8 ohm and 5 ohm in series respectively, such that equivalent resistance is 25 ohm? Here, first resistance is 8 ohm, second resistance is 5 ohm, third resistance is not given, and here it is given resistance in series, overall resistance is 25 ohm. Now we know overall resistance in case of series, it is R1 plus R2 plus R3 equals to 25 ohm. R1 we know it is 8 plus 5 plus R3 equals to 25. So R3 equals to 25 minus 8 plus 5 13. So it will be minus 13, which will give 12 ohm. Therefore 12 ohm is the unknown resistance. In practice problem 8, question number 1, in figure 3.32, calculate the total resistance between points A and B and between A and C. Now in case of point A and B, all the resistances are in parallel. So overall resistance will be 1 by 6 plus 1 by 3 plus 1 by 2 equals to 1 by Rp. After calculating the overall resistance from these three, that resistance will be in series with this one. Here these three resistances are in parallel. So resistance between A and B, that is 1 by RAB, will be 1 by 6 plus 1 by 3 plus 1 by 2, because these resistances are in parallel. Here LCM will be 6. 6 divided by 6 1, 1 1 ja 1, plus 6 divided by 3 2, 2 1 ja 2, plus 6 divided by 2, it is 3, 3 1 ja 3. So it will be 3 4 5 6, 6 by 6 it will be 1. Therefore RAB equals to 1. So resistance between A and B is 1. Now from this part we got 1. So our circuit will be, this is A, this is your B, and this point is C. This is 1 ohm, this is 1 ohm. Now resistance between A and C, these two are in series, so it will be added 1 plus 1, which will give 2 ohm. Therefore resistance between AB is 1 ohm and resistance between A and C is 2 ohm. In practice problem 12, first question is, a current of 0.2 ampere flows through a conductor of resistance 4.5 ohm. Calculate the potential difference at the ends of the conductor. Here current is 0.2 ampere and resistance is 4.5 ohm. We have to find the potential difference. From Ohm's law we know V equals to IR. So here I equals to 0.2 and R equals to 4.5. So if I multiply, it will be 0.9 volt. Therefore required potential difference is 0.9 volt. In page number 151, practice problem 1, first question is, calculate the energy consumed by a heater which draws a current of 5 ampere at 220 volt for 1 minute. Here current equal to 5 ampere, potential difference is 220 volt and time equal to 1 minute, which is 60 seconds, and we have to find the energy consumed. Now energy consumed or work done, we know it is VIT, V into I into T. Here V is 220 volt, current is 5 ampere and time is 60 seconds. So it will be 220 into 5 6 ja 30, 300, 66000 joule. So the energy that is required or consumed by the heater is 66,000 joule. In practice problem 2, question is, an electric kettle draws a current of 4 ampere for 2.5 minutes. If the resistance of its element is 100 ohm, calculate the electrical energy drawn by the kettle in kilojoules. Here it is given that current equals to 4 ampere, time given 2.5 minutes, which is equals to 2.5 into 60 seconds. 2.5 into 60 will give 150 seconds, and it is given that resistance of the element R equals to 100 ohm. Now we have to calculate the energy consumed. So energy consumed, you have to write I square RT, because here resistance is given, current is given and time. So we have to use this relation. Here I square will be 4 square, resistance is 100 into time is 150 seconds. 4 4 just 16 into 100 into 150, it will be in joule. 15 into 60, it will be 240. So 240 into 0 0 0, it is 240,000 joule. If you want to express in kilojoule, then it will be 240,000 divided by 1000 kilojoule. 3 zeros can be cancelled, so we are left with 240. So 240 kilojoule is the required answer. In practice problem 4, question is, an electric heater draws a current of 3.5 ampere at a potential difference of 250 volt. Calculate the power consumed by 4 such heaters. In case of electric heater, it is given that current is 3.5 ampere and potential difference is 250 volt. So power consumed by one heater, power we know it is V into I. So it will be 3.5 into 250 watt. Now as given in the question, there are 4 such heaters. Therefore power consumed by 4 heaters, this quantity will be multiplied by 4. So 4 into 3.5 into 250 watt. Now 3.5 into 4 into 250, it will give 1000 watt. So if I multiply, it will be 35000 here after decimal 1 place. Therefore required power will be 3500 watt. In practice problem 5, question number 1, an electric heater has a resistance of 40 ohm and draws a current of 4 ampere. Calculate the power consumed by the heater and the potential difference applied at the ends of the heater. Here resistance is 40 ohm and current is 4 ampere. We have to calculate the power and the potential difference. Now we know power equals to I square R. So we can write P equals to I square R. Current here is 4. So it will be 4 square into 40. 4 4 is 16. 16 into 4, it will be 64. So it will be 640 watt. So the power consumed is 640 watt. In the second part it is given, we have to find the potential difference. For potential difference we know V equals to IR. Here current is 4 and resistance is 40. If we multiply, it will be 160 volt. So 640 watt is the required power consumed and the potential difference is 160 volt. In practice problem 8, question number 1, a geyser is rated 2000 watt and operates 2 hours a day on 200 volt mains. Calculate the monthly bill of running the geyser when energy cost rupees 3.80 per kilowatt hour. Power equals to 2000 watt. It is given daily. We are using it for 2 hours. So time is 2 hours. And here voltage is 200 volt. We have to calculate the monthly bill of running the geyser when energy cost rupees 3.80. We know energy consumed is power into time. Here power is 2000 watt and time is 2 hours daily. So it will be 4000 watt hour, which will give 4 kilowatt hour. So that means daily energy consumption is 4 kilowatt hour. Therefore energy consumption in 30 days, it will be 4 into 30 kilowatt hour, which will give 120 kilowatt hour. Now it is given that for each kilowatt hour we have to pay rupees 3.80. Therefore monthly bill, it will be rupees 3.80 into 120. If I multiply, it will be rupees 456. Therefore monthly bill will be rupees 456. I hope these sums are clear, and rest of the sums of the book you can try it yourself. Thank you for watching.